Hi, fourth graders. Today our lesson is pretty short and sweet again. This is for 9-5 multiplication and division stories. Our learning goal says I can use words and models to represent multiplication and division problems accurately. So we're going to take what we've learned so far from multiplication and division lessons, and we're going to apply it to some word problems. You do not need to write out all of the word problems, but you do need to choose one to focus on, please. In order to be able to solve multiplication and division stories or word problems, annotating is key. So a friendly reminder, we're always going to circle important quantities, underline keywords, and put a star by the question that we're focused on. So in this word problem, it says, Ben has $55 to buy helium balloons for the end of summer camp party. So if I read that sentence again, I circled $55 because I have an important value, 55, and an important label, dollars. I'm also going to underline balloons because that's what he's using the money for. The next sentence says, the balloons cost $9 per bunch. Again, I circled the important number and I underlined the important words. Lastly, it says, how many bunches of balloons can Ben buy? So what I need to think about here is based on the numbers that I'm given and based on the labels that I'm given, what operation am I using? So one way that I can do this is by looking for, do I want to combine equal groups or do I want to find the number of groups? So if I'm combining the number of groups, that often means I already have the groups and I want to find the total, so I would multiply. However, if I have the total and I want to know how many groups there are, that's when I would divide. So let's look at this example. He has $55. That's the total amount of money he has. And he wants to break it into groups of 9 so that he can figure out how many bunches of balloons he can buy. So since I'm looking for how many groups, I'm going to use division in this problem. So I have $55 and I want to divide it into groups of 9. So I'm going to go through my algorithm, divide. How many times does 9 fit into 5? It doesn't, so I'm going to move on. How many times does 9 fit into 55? Well, I know that 9 fits into 55 6 times. I'm going to multiply 6 times 9. That's 54. I'm going to subtract to see what I have left. That's 1. I have nothing to bring down, so that what's left, the 1, the R, is the remainder. So let's interpret the answer. This is saying that Ben, if he has $55 and it costs $9 per bunch of balloons, he can buy 6 bunches. He can't do anything with the remainder unless the problem said that he could purchase part of a bunch or a single balloon. So in this particular problem, I am dividing. I'm using my long division algorithm, and I found that he could buy 6 bunches of balloons. Let's try another example. The problem says, Anita is making costumes for a play. Each costume requires 3 yards of fabric. How many yards of fabric are needed to make 12 costumes? If Anita has 26 yards of fabric, how many costumes can she make? So before you even jump into trying to solve, you need to annotate because this is actually asking you 2 very different questions, even though they're related to the same situation. So I'm going to read through it again. Anita is making costumes for a play, so I know my situation. I notice the word each. Each costume requires 3 yards of fabric. Now, I intentionally wrote this so that we would have to look carefully. When we look at quantities, we often are looking for numbers. However, sometimes the quantities are written in word form. So in this case, we have to be careful. 3 is written out in word form, even though it represents a quantity. I also underlined yards because that's the measurement of how much fabric. And then I have 2 questions. The first question asks me how many yards of fabric are needed. So how many yards of fabric are needed to make 12 costumes? And then I have a second question that says, if Anita has 26 yards of fabric, how many costumes can she make? So I've got two different questions here based on the same situation. So let's tackle the first one. So she knows that she needs 3 yards of fabric per costume. If she wants to make 12 costumes, we don't yet know how many total yards she needs. That's what we're finding out. So that first question is actually a multiplication problems. 12 costumes, and they each need 3 yards of fabric. 12 times 3 is 36. So the first question, Anita would need 36 yards. You can also use YD for an abbreviation for yards. In the second question, I have a different situation. I know how much total fabric she has, and I want to break it into equal groups. The equal groups are 3 yards of fabric each. So I'm going to take the 26 she started with and break it into groups of 3. I'm going to ask myself, how many times does 3 fit into 2? It doesn't. So I'm going to look at the 2 digits, 26. 3 fits into 26 8 times. I'm going to multiply 8 times 3, that's 24. Notice how I'm lining up my digits very carefully. I'm going to subtract 26 minus 24 is 2. I have nothing to bring down, so whatever's left is the remainder. So let's interpret this answer. As you become closer and closer to being 5th graders, you're going to notice that sometimes even if you come across an answer, you have to interpret it. You have to think about, what does this answer mean? So in this situation, the answer means she can make 8 costumes, and then she's going to have 2 yards of fabric left over. She cannot make an extra costume with that. She needs 3. So you would write down 8 costumes with 2 yards remaining or left over. So notice how even though reading, rereading, and annotating does take a lot of work before you do the math, if you do those 3 things, you're going to be much more successful when you solve word problems. Let's try one more problem together before you practice on your own. The problem says, Ben ordered 15 pizzas for a party. Each pizza had 8 slices. How many slices of pizza were there in all? Using your answer, how many people at the party could each eat 2 slices? So again, let's look back at the context. So we have Ben, he's ordering pizzas for a party. So there's 15 pizzas. 15 is the quantity, pizzas is the label. Each pizza had 8 slices. So I know that each one of those 15 pizzas has 8 slices in it. The first question is asking me, how many slices of pizza were there in all? So I know the groups and I know how many are in each group, but I don't know the total. So that one should tell you you're going to be multiplying. Let's look at the next one. It says, using your answer, how many people at the party could each eat 2 slices? So in this question, I need to figure out, based on the total I have, how many people could each eat 2 slices. Again, be careful. The number 2 is written as a word. I have to figure out how many total slices there are, and then I have to break it into groups of 2. So this question tells us that I need to be dividing. I'm taking the total number of slices and I'm breaking them into equal groups of 2. So first things first, let's solve the question for multiplication. There are 15 pizzas and there are 8 slices in each. So 15 groups of 8. 5 times 8 is 0. Recall from our last unit, carry the 4. 8 times 1 is 8, plus 4 is 120. Okay, so this tells me the total number of slices. That's how much pizza he ordered. That's how many slices there were total. On the flip side, I have 120 slices. I want to break that into equal groups of 2. So let's think about this. I have to divide because I know the total, and now I need to break it apart. So 2 doesn't fit into 1, so I'm going to look at the next digit. 2 fits into 12 6 times. I multiply 6 times 2 is 12. I subtract, bring down. I'm bringing down a 0. How many times does 2 fit into 0? It fits in 0 times. 0 times 2 is 0. I subtract, I have nothing left over. So let's interpret this answer. 120 slices divided into groups of 2 means that 60 people could each eat 2 slices. So my labels for these 2 questions, even though they're in the same problem, are different. One had to do with the total number of slices, the other had to do with the number of people. So what we need to focus on from this particular lesson, if we go back to our learning goal, is that we're using words and we're using models to represent multiplication and division problems accurately. So you now have learned enough multiplication and division that you can be given either type of problem and know whether or not you are going to be multiplying or whether or not you're going to be dividing given that situation. And now, here's Mr. Garreau with his next great joke.
I've got a science joke for you today. Hey, Mrs. Garreau, what did the sea say to the shore?
I don't know.
Nothing, it just waved.
Bye, everybody.